Hello everyone, welcome back to the 5 Minute Tech channel. Today we will be talking about the facade pattern in this series of C-sharp design pattern. This is the part 4 of the series in which we'll be talking more in depth about the structural pattern, which is one of the structural pattern, which is the facade pattern. So let's get started. So as we have gone through, this is the full structure, full design pattern list, and we are right now talking about one of the structural patterns called facade pattern. So facade pattern is among one of the more commonly used structural patterns along with adapter bridge decorator. So let's get into the detail of the facade pattern. The intent of the facade pattern is to provide a unified interface to a set of interfaces in the subsystem, like a super interface which can talk to other interfaces. It defines a higher level interface that makes the subsystem easier to use and access. The facade pattern, UML diagram and implementation is on your screen. The first part is the client. The client uses the facade instead of calling the subsystem objects directly, and facade internally has the implementations or the interfaces of the subsystems through which it can interact with different subsystems and get you the information which your system may require. The facade provides the convenient access to a particular part of the subsystem's functionality. It knows where to direct your call or client's request and how to operate all the moving parts. Whereas subsystems consist of dozens of various objects or functionalities. To make them all do something meaningful, you have to get into the details of all the subsystems implementation and initializing objects and correct order and supplying them with the data in the proper format, which the client doesn't want to do. So what it does, it uses the facade pattern. So this is a simple example. We'll now get into a demo. So you would have seen very commonly this kind of screen wherein you are seeing number of discounts that come into the system. So what we will be doing is we will be using a facade pattern and trying to get the idea on how a discount scenario applies to a practical facade scenario, so that we can map to our understanding on how a facade pattern works. So we are now in Visual Studio. I've created a simple ASP.NET Core web API project, and this project has a couple of important things. First is, let's go into the implementation folder. There are 3 types of services which I'll be using. So consider there is a discount which requires a particular date and time. For example, if it is over a weekend where there is a heavy rush, you may not have an implementation to provide a discount. As demand search period, then return false, that it will not have any discounts. There is a discount base wherein you can get the basic discount which can be applied to all the products. That is one implementation. And then there is an order service wherein seeing how many orders the customer has done before. On that basis, we are providing a random discount. I'm just providing a number of a discount value. And similarly, we have the discount facade. The discount facade, what it does is it has that inject dependency injected into it, and those are of the date time service, the discount based service which I just talked about, and the order service. And what it does, it calculates a discount amount. So the client, being the API caller, which is our controller, doesn't need to know what is happening inside the discount facade or what are the subsystems which it is interacting with. It just cares about get me the discount. So in the discount facade, what we do basically is we just get the discount base first, and then if it is a number of previous order is there, then what we do is we give a particular discount, and then if there is a demand surge is there, then we make the discount as 0. So let's just run this application. Before running, we'll just show you the controller also. Controller has that get discount method, and which calculates the discount from the facade implementation as I just showed you. So let's run this application now. So my application is now running, and the Swagger has come up now. I'll just run some value to it. So if I apply 100 to this, I will get a specific discount. So let me just put a breakpoint here. So I am putting a breakpoint in my facade, and also I will put a breakpoint in my controller. So now when we run this with 100, what happens, it goes into the controller, and from there, and I go inside the facade, which is my discount facade, I get this I get into this. So I get into the specific services, get the specific values. So each of these services will now return a specific value, and that will be what will be used to get the discount. So it is returning 1, returning false, and then I will be able to get the 0 discount because it should be greater than 10. So let me run this now and see the value there. So you would be seeing amount of 0. Now if I run it more than like maybe 8,000, and then I can show you, let me remove the breakpoint now, it will be more than 50 or something. Yeah, it is 50. So that's the implementation wherein Facade takes care of the internal logic, and the class client, which is the controller here, only talks to the Facade. So when to use the Facade pattern? Use the Facade pattern when you need to have a limited but straightforward interface to a complex subsystems or underlying implementation. Use Facade when you want to structure a subsystem into different layers. How to implement Facade? Check whether it's possible to provide a simpler interface than what an existing subsystem already provides. Declare and implement this interface in a new Facade class or wrapper implementation. Then the Facade should redirect the calls from the client code to your appropriate objects of the subsystem. It takes care of all the processing. To get the full benefit from the pattern, make all the client code communicate directly with the Facade itself. And if Facade becomes too big, you can have extraction and refine your Facade classes. Use cases of Facade pattern. The example is you're integrating with legacy system wherein your subsystem is a legacy system and you want to integrate with it. Content management system, different sources of content. Multimedia playback, different types of multimedias are there. So your subsystem becomes those multimedia. Payment processing, different kinds of payment which you can take care through the Facade pattern. Now, pros and cons of Facade pattern. You can isolate your code from the complexity of the subsystem by having a Facade pattern, and open close principle wherein it promotes weak coupling between the subsystem and the client. A Facade can also be a problem wherein it becomes the sole go-to God object, which is coupled to all your subsystems and is the only interface to your clients. Now, related patterns to Facade pattern is Abstract Factory. It provides an interface for creating subsystem object. Mediator, it abstracts the functionality of existing classes, but its purpose is abstracting communication between the objects, whereas Facade is about promoting ease of use. Adapter, make existing interface usable by wrapping one object, while with Facade you are defining a new interface for the entire subsystems. Yeah. So that's pretty much about the Facade pattern. I hope you like the rest. Like and subscribe to the channel. Have a nice day.